Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number, which is 98367930076. If you have any mathematical query or doubts or anything, please feel free to ask on that number. That means you can call on this or you can do a WhatsApp. And another thing, if you want to share your doubts to our us, you can drop an email to our email ID, which is sourofsirclasses@gmail.com. Okay, so please feel free to contact us if you need any help from us. If you join to our regular batches and our one-on-one sessions, our online classes, so that will be beneficial for your upcoming examinations. That means the ISI, ACMI entrance test and various any other examinations also. So please feel free to contact us. Okay. So now we are going to solve a problem that is appeared in the ISI MTech QROR MCQ section, and the question is telling us that suppose that f be a differentiable function satisfying fx plus f dash x equals to sin x plus cos x for all x belongs to R, and our f is running from R to R. Okay, so f is a real valued function here. So where f dash is the derivative of f, then f is a bounded function if and only if there are four options here: f0 equals to 0, f0 not greater less than equals to 0, f0 greater than equals to 0, and f0 greater than 0. Okay, so now what can be done? Yeah, now I think it's visible. Okay, so we are given the differential equation, which is fx plus f dash x, that is equals to sin x plus cos x. Okay, so we can rather we can write it as our y dash plus y equals to gx in that form. So our gx is my sin x plus cos x, y is my fx. Then we can see that that can be the auxiliary equation of it will be m plus 1 equals to 0, then it will be m equals to minus 1. Okay, so our integrating factor in this case will be e to the power x. We can see that. So now we are multiplying both sides with respect to e to the power x, so we will get e to the power x f dash x plus e to the power x fx, that is equals to e to the power x into, let me shift the screen. Okay, that is sin x plus cos x. Okay, so now rewriting the left hand side, we will get what? We will get e d dx of e to the power x fx. Easily we can see that our derivative of fx will be f dash x, then our e to the power x is constant, and our e to the power derivative of e to the power x is e to the power x, so then we will get fx. So this can be written as d dx of e to the power x fx. Okay, so that will be equals to e to the power x sin x plus cos x. Okay, very good. So after that, what can be done here? Yeah. So now we are going to compute the integral. That means we can write it as e to the power x fx will be equals to integral e to the power x sin x plus cos x dx. So we have to only integrate this part. Okay. So now let us write on this side. That means we are going to calculate the integral. So what we will get? So we now getting this thing. Okay. So we can write it as, that is equals to e to the power x sin x dx plus integral e to the power x cos x dx. Okay. So let us call it j and let us call it k. Okay. So now we are going to solve our j, then what we will get? So our j is equals to integral e to the power x sin x dx. Okay. So now let us take our u equals to sine x, and our then our du will be what? Du will be cos x dx. And let us take our v equals to e to the power x, then our dv will be, sorry, dv will be e to the power x dx. Okay, so we are now using the integration by parts. So we get j equals to will be e to the power x sine x minus e to the power x cos x dx. Okay, as we took e to the power x cos x dx is equals to k, so we can write it as k. So we can write j equals to e to the power x sine x minus k. So okay, leave it now. So we are now going to calculate our k. So let me change my color. Yeah. So our k is equals to integral e to the power x cos x dx. Okay. So what can be done here? So let us take our u equals to cos x, then our du equals to minus sine x dx. And after that our vb e to the power x, then our dvb e to the power x dx. Okay, so our kx will, so our k will be what? E to the power x cos x minus of e to the power x, sorry, that will be e to the power x minus sin x dx. Okay, then what will happen? So our minus will come outside, so we will get e to the power x cos x plus e to the power x sin x dx. So this thing is my j, we know that. So we can write our k equals to e to the power x cos x plus j. So we can write this as j plus k is equals to e to the power x sin x, and k minus j equals to e to the power cos x. So after adding these things, what we will get? That is 2k equals to e to the power x sin x plus cos x. So our k is equals to half e to the power x sin this. So now we have to check our integral. That means our k is this, and what is our j? So we have to calculate j here. So our j is equals to e to the power x sin x minus k. So that is equals to e to the power x sin x minus e to the power x by 2. Then there is sin x plus cos x. So that will be half e to the power x bracket sin x minus cos x. So we got this thing. Then, okay, yeah. So our integral e to the power x sin x plus cos x is equals to what? Okay, this thing is unnecessary here because we got j plus k equals to e to the power x sin x. So this part is unnecessary. Okay, so our e to the so our this integration will be, so we got e to the power x fx equals to e to the power x sine x plus c, because we got k plus j is equals to e to the power sine x, then we got this thing. So we can write it as our fx is equals to sine x plus c into e to the power minus x. Then what is our c? So we have some initial conditions here. Yeah. So we have to think only. Okay. No, there are no initial conditions. So we have to think for our f0 only. So okay, what is our f0 here? So our f0 will be sine 0 plus c into e to the power minus 0. So our f of 0 is equals to 0 plus c into 1. So our f of 0 is some constant only. Okay. Yeah. So only this thing can be concluded from here. Okay, hope you understood, guys. Again, I am telling that if you have any queries or any doubts, please feel free to ask us. Okay, thank you guys. Hope you understood. Thank you guys.